Hello and welcome that we have already applied the diaphragm for our today's lecture. So for connecting with this series, you have to visit our previous two videos regarding this tutorial series. So in this session, we will cover the basic use to the advanced level of ETAB. Actually, in previous tutorial we have done with the modeling, assigning a frame element, slab and diaphragm. In today's lecture we will cover in the define tab, and in the same tab we will use the load patterns, load case and load combinations. So today tutorial is very simple and you can get a basic knowledge about how to apply the load patterns. So today I will tell you some tricks about using the shortcuts in ETABS. So first of all you need to go to the option tab. Clicking on option tab you have open customize toolbar. Click here is the key option. By using this key option you can press any key which you want to, like I already pressed exit key. If I am come out from a command then I will use escape, like here already I have applied the escape key already here. So I just click OK. Then if I select something here on this model, so it will be used by escape key to come out from that command. So let's start with our today's session's basic point, that we will press on the define, then we have to go to the load pattern. Actually dead load is sulfate of the model, the thickness of slab, the frame load, the beam load. You know frame is beam and column. So these two loads including your slab load, it will be dead load and it is multiplier will be 1. It means that software will calculate all these loads. If you are providing some superimposed load or additional loads, the software will not calculate. The software automatically will not calculate. It depends on the intensity, like area load or line load, whatever you are going to provide. So live load, we will already, this is two type of loads already given. If I want to provide a superimposed dead load, one additional load, then I will consider the type of load is dead load or super dead, and the multiplier will be 0. Then we have to apply the wall loads. I just consider wall loads WL, and it's also superimposed dead load, not a okay. Then we have another type of loads is superimposed dead load, maybe the marble load, the finishing load, or some additional occupancy load. It depends on the usage of the building and the purpose of the building which you are going to be designing. So we have applied the wall loads here. Now we have the option to apply our, actually we are doing the structure into two types of analysis. One is static analysis, another is dynamic analysis. For static analysis we just apply the static procedure EX, earthquake in X direction, and we call it seismic. Okay. Then we have the codes. Actually there are a lot of number of codes. It depends on your region and the code you can apply from on base of your region. So we just here you can see a lot of codes. UBC 97 actually we are using building code of Pakistan. I will use UBC 97. Okay, seismic code. Just I will add and I will modify this load, modify lateral load. So actually all tabs are here on, so I just click because I am only using earthquake in X direction, and my soil type is ST in my case, and I am working in zone 3. For zone 3 So these two things, 0.36, 0.54, these coefficients are later used in dynamic analysis in the response spectrum. These 2 points, Ca and Cv, these coefficients. And this eccentricity I will put 5%, okay, and over strength factor in my case, because I am working in special movement resisting frame, so it will be 8.5 by building code of Pakistan. Importance factor I keep 1 because my category is falling in E1. So you need to go through your code and understand the complexity which are using to design the building. Just I will copy, modify this load, and I just add E Y, and I will add, and I will modify. Just I will uncheck all the X parameters and I will put SD. Initially I consider SD and I consider 0.3, and the same coefficients are used later in dynamic analysis. And this is 8.5 because already explained, okay. So we have done with the loads based on our requirement, our inputs. If later some loads need to be added, we will add in the same load pattern. Just click OK. Now you head on with the load patterns. Then you have load case. Load case will show you the which type of load case, whether this is a static or this is a dynamic. So I will add one two load cases more, because earthquake I consider it based on the layout of the structure, type of the structure, zone, and many two or three factors which you can read from your code. So I consider as for dynamic analysis, if required, I just add OK, add new case. New case I consider earthquake QX. Okay, I will consider this response spectrum. But first of all, I need to define the response spectrum and mass source. Okay, for this I just click here OK, and I define my function response spectrum. So I add from UBC 97 response spectrum. You can use UBC 97 or add function. I will add function response spectrum RS 5% damping, and the user defined no. This will be response spectrum, and this is not my code. I will use UBC 97. I need to change this code. UBC 97. Now add new function response spectrum. As we already know, this is 0.36 and 0.54. 5% damping, okay. Linear, okay. Just click OK. Now we have defined our response spectrum. If you want to delete this one, delete this spectrum and consider this one. Then you have to define the mass source. Mass source, I keep this mass source and modify this mass source. Mass source, I will just additional mass source, specified mass source, okay. Mass source, specified pattern, dead load, I consider this one 1. All other dead loads, superimposed dead load, you need to consider it's 1. Superimposed dead load 1. Okay, then you have the live load. It depends on your time period. On your live load. If 4.7 or something, whatever your code allowed, you need to, I consider as 25% head, including vertical mass. So if I going to further twist, I will consider this one. Okay. So it's both elements self weight at once, load pattern with self element multiply by 0. So let me check modify dead load. Dead element self mass already included, so no need to include this dead load. Delete from this point because already we have checked this one. Okay, so we have done with the mass source. Now we can directly go to our load case, and in load case I am going to add new load case. Just click here and EQX. Here is our response spectrum, and we have mass source. Okay, and we have the model EQX. Okay, combination method add add, and we are EQX, and we consider this acceleration and U3, and now initially keep this vector same as it is, and this function will be RS. This will be RS response spectrum, and a 5%. Okay, diaphragm is 5%. Okay, for all diaphragm, alright, and then you need to click OK, and the same copy the add load case. From here you need to U2 and Y. Just click OK. These two are for the dynamic analysis, other are for static analysis. Then we will check, we will do for both dynamic and static analysis. Just click OK. And the load combination will be, we will use after applying all the loads. The loads we have already defined in load pattern. We will assign that loads after application of their magnitudes. Like we have in our building the uh, exact amount of loads after calculation, background calculation or some additional calculation. Then we apply that loads on our structure, on our model. So then we will go after the finalization of all the loads, we will apply load combination. So in next session we will cover how to apply the loads, live loads, dead loads, and after that application we combine the loads, and then we will run the analysis. After run the analysis we will check whether our element is fulfilled or not. If not, we will add additional, increase the size of element if possible, then or we can uh, change our number of elements, we can increase or we can decrease our number of elements for the economy purpose. So it depends on the after analysis result. So this is enough for today. Thank you.